All right, this is section 2.1, equations of lines. And I'm going to, well, let's look at the equations first. So there's two equations that we're going to use. One is the point-slope form. And it says that the line with slope m passing through the point x1, y1 has equation y equals m times the quantity x minus x1 plus y1. Or y minus y1 equals m times x minus x1. We'll notice that that one is just subtracted. This one with a y minus 1 subtracted. It is called the point-slope form of the equation of a line. It's called the point-slope form because if you have an equation in this form, if you're given an equation in this form, that number m is given to you, and so is x1 and y1. Okay, notice x1, y1 is the coordinates of the point, and m is the slope. So you'll see a number or a constant in place of m, like 2/3 or 1/2 or negative 1/2. And you'll see a number in place of x1, you'll see a number in place of y1. Similarly, if you know the slope in a point that a line goes through, you can write this form of the equation, or either one, by replacing the slope that you know and the point that you know that the line goes through. Again, remember it's the point slope because it's showing you a point, x1, y1, and the slope. The slope-intercept form, that's the other form we're going to see, is the line as follows. The line with slope m and y-intercept b is given by that equation, the slope-intercept form of the equation of a line. Notice when you have this equation, you'll have a number in place of m and a number in place of b, a constant, yeah, like y equals 2x minus 1. And when you have that equation, if you're given an equation, the coefficient of x is the slope, and b is the y-coordinate of the y-intercept. Okay. Or if you know the slope and the y-intercept, then you can write the equation in this form. Again, notice slope-intercept because you're dealing with the slope and the y-intercept. All right. We also want to know about intercepts, and these are where the graph crosses the axis. So you have two axes, and therefore you can have two intercepts. One is the y-intercept, where your line crosses the y-axis. Remember, the y-axis is this one, and your line is going to cross somewhere there. Let's say your line crosses here, if it's going like that, let's say, or like this. So the coordinates are 0, -2. You'll notice that's why x equals 0, right? Because anywhere on the y-intercept that the line crosses, the x-intercept is 0. Like, let's say it crosses up here. That's 0,5 or 0,4 or 0,3 or 0,2 or 0,1 and so on. All right. For any x-intercept, y equals 0, and the x-axis is right here, and so the x-intercepts are going to be on that axis. And you notice any point you pick, let's say we pick this point, the coordinates are -3, 0, or if you pick that point, the coordinates are 2, 0. Notice the y-coordinate was 0. And that happens, by the way, whether you see the graph of the line and you see the intercepts, or whether you have the equation of the line. So on the equation for the y-intercept, x is 0, and on the equation for the x-intercept, y is 0. All right, so how do we use that knowledge? Let's try example number 1, and we'll find one of these. We'll find the x-intercept, okay? So I'm going to find the x-intercept, and I'm going to write a little note for myself. For the x-intercept, y is 0. All right, so then my equation becomes x plus 3 times 0 equals 6. Let me zoom this in. Be a little bit easier to see. Okay, so I got 2x plus 3y equals 6. So this is 2x plus 3 times 0 equals 6. And so 2x equals 6. And if I divide by 2, I get x equals 3. Now, what does that tell me about the x-intercept? Well, remember, x is 3 and y is 0, and that makes the point 3, 0. Okay, so the x-intercept is 3, 0, which will be over here on the graph. It'll be right there. Okay, and I'll let you guys, if you'd like, on your own, to find the y-intercept, and we'll see that part in class. Okay, so we have the x-intercept. I'm going to put plot that point right there. All right, let's go on to equations of horizontal and vertical lines. So these are a little bit special because they have a certain way of looking. So horizontal lines are of the form y equals b, y equals a number, right? So maybe like y equals 2, right? And remember, y is also f of x. So in function notation, you have f of x equals b. And remember, that was called a constant function. All right. If it's a vertical line, it is the equation is of the form x equals k. And again, k will be a number like x equals 2 or x equals -1 or x equals, right, any constant. All right. So let's try the example. Find the equations of vertical and horizontal lines passing through the point 2, -3. So we'll do the vertical. And then we'll leave the horizontal for class. Okay, so first I'm going to graph it. Notice it's not asking us to graph it, but I'm going to graph it. So it's a vertical line through the point 2, -3. 2, -3, if I plot that point, is right there. I'm actually going to draw the line. So it's a vertical line going straight up and straight down. Okay, and so I have to write an equation that says x equals. So how do I write that, and what am I using? Well, any equation for any line is a rule. It is a rule that the coordinates, each coordinate must follow this rule. So for example, this coordinate on this line up here, if I plug in x and y in there, that gives me a true statement. 2 times 3 is 6, plus 0 is equal to 6. And any pair of points that are on the line, when I plug them in here, the coordinates, they'll give me a true statement. Okay? It has to be the same thing with this line. So this vertical line, when I write x equals whatever I'm going to write, it has to be a true statement. And so notice that says x equals. And so if I look over here, and if I look at the coordinates of some points, I'll start with 2, -3. And then I can also see 2, -2, 2, -1, 2, 0, 2, 1, 2, 2, 2, 3, and so on and so forth. So what can I say that x equals, knowing the coordinates of each of those points that are on the line? Well, if you notice, when I set the coordinates, 2, 4, 2, 3, 2, 2, 2, 1, 2, 0, 2, -1, 2, -2, 2, -3, every time I said x equals 2. And that is the equation of that vertical line. I can put a little square on that. All right, let's go on to number, again, we'll leave the horizontal for class. Let's go on to the next page, parallel and perpendicular lines. So how do we identify parallel lines? Well, they have the same slope. Notice when we see them on a graph, they look like they're parallel, but when we look at their slope, they have to be the same. Perpendicular lines, the product of their slopes is -1. Or we can also think their slopes are negative reciprocals. Negative reciprocals means they're the opposite sign and then they're reciprocal. So if one of them is -3/2, the other one's +2/3. Or if one of them is -1/2, the other one is +2/1, which equals 2. Or if one of them is +1/2, the other one's -2/1 or -2. All right, so let's work out one of these. Find an equation of A, the perpendicular line to, and B, the parallel line to, y equals 2/3 x minus 2. So that's a line that we're given, and then we have to find a line perpendicular to that, and then a line parallel to that. And passing through 4, -1. Okay, so what do we use for this? We have to find an equation. So we go back to our equations, and we have two choices. One is if we know the slope and a point on the line, and the other is if we know the slope and the y-intercept. Well, we know a point on the line, so this is going to be x1 comma y1 for either equation that we choose to use. I think we're going to use this one because this is the only one that says we go through the point x1 y1. Okay. Then we need the slope. So do we know the slope of a line perpendicular to this line? Well, the slope of the perpendicular line has to be the negative reciprocal of 2/3. So the slope for this guy is going to be, the negative reciprocal will be -3/2. Okay, so I now have the slope and the the point on the line. So I'm going to write it in this way: y equals m times x. Okay, so y equals, and I know my slope, so I'm going to leave a blank for my slope, times x minus, and I'm going to leave a blank for x1, that's the point, plus I'm going to leave a blank for my y1. Okay, again, this is m, maybe I'll write them up here, m, this is x1, and this is y1. That's what goes in the blanks. Okay, so my slope is negative 3/2 for this line, right? Because I'm looking for the perpendicular to that one. My x1 is 4, and my y1 is negative 1. And so I have my equation right there. Y equals negative 3/2 x, 3/2 times x minus 4 minus 1. Do I need to change anything? Well, I want to write this as a minus, but that's it. Okay? So I want to leave it like, or do I have to? Actually, I can leave it like this, right? It's in point slope form. So I'm done. Let me just write it with the minus there. So y equals negative 3/2 times x minus 4 minus 1. There's my equation. It is in point slope form. Okay? All right. Now, so that's a good answer because they didn't specify which form. I can answer like that. What if they wanted slope-intercept form? Because they can ask me either form. All right. Well, we would distribute right here and just simplify. So we would have y equals and then mx plus b. Let's do that. So y equals, if we want it in slope-intercept form, negative 3/2 times x is negative 3/2 x. Negative 3/2 times negative 4 is plus 6 minus 1. Okay, and that's at minus 1. And then just combine like terms. So you'd have y equals negative 3/2 x plus 5. Okay, so this is in slope-intercept form. And I could answer either one because it doesn't specify. Okay, all right. We're going to leave the line parallel for class. So we did A, and then we will do B in class. All right, so I'm going to stop part 1 here, and then I'm going to finish on part 2 video.